A really common issue we have when we're troubleshooting a GRE tunnel is that one of the routers on either end of the tunnel, they don't know how to get to the other router. Remember, when we set up a tunnel, we specify a source IP address and a destination IP address. Maybe I'm on the source router and I specify this destination address of, like we just did, 3.3.3.3. If my IP routing table does not know how to get to that destination, then I'm not going to be able to form a tunnel. Let's go to the live interface and see how we might determine that that's what's happening, and how do we resolve that. Let's go over to R1, and our tunnel on R1, notice we have a destination IP address of 3.3.3.3. Our source is 1.1.1.1. One of the things I would want to check is I would want to confirm that I can get to 3.3.3.3. Can I ping it? Can I ping 3.3.3.3? Yes, I can. I had one of them time out. Let's try that again. That's better. 3.3.3.3. We can successfully reach that. Fantastic. Can R3 get back to me? Let's check it out. Let's go to R3 and let's say, can I ping a 1.1.1.1? Yes, I can. They can ping one another. That's great news. That would be our verification to see, do I know how to reach the far end of this tunnel? If we don't, then we've got some sort of underlying IP routing issue. We could do a show IP route and check out our routing table and start to investigate, why do I not know how to get to this far end? Why is it not showing up in my routing table? Something else that could be going on, let's go back to our slides. Something else that could be going on is that we have recursive routing going on. Here's what I mean by recursive routing. We just made the point that our IP routing table needs to know how to get to the destination IP address of our tunnel. What if that destination IP address route entry in the IP routing table says, to get to this IP address or to get to this network, here is your egress interface, and the egress interface is our tunnel interface. In other words, it's kind of a paradox, isn't it? It's the way to form this tunnel is to send packets to this destination IP address, and the way you get to this destination IP address is through this tunnel that you're trying to form. What can happen there? We can get some unpredictable behavior. We can get flapping of that interface. The tunnel interface can go up and down, up and down, up and down. That's not a good thing. And we can determine that that is indeed what's going on by taking a look at our routing table. We can do a show IP route, and if that destination IP address or its network has an egress interface of the tunnel interface, that could be an issue for us. It's a pretty easy fix, though. We can look at our topology and realize, no, to get to this destination IP address, I don't want to go down my tunnel. I want to go to my neighbor. Maybe my neighbor is 10.1.1.2. We could go in and we could statically configure a route to say, to get to this destination IP address, we specify, in my case, it would be something like 3.3.3.3. To get to that destination of the tunnel with a 32-bit subnet mask, we're going to a specific IP address. The way to get there is to go to this next hop, and that next hop, that's going to be the IP address of our neighboring router.